What's up, Tau Beta Pi? It's Eric Graham coming to you with another FE exam workshop video in the electrical computer section. And for all the students out there who are electrical or computer engineering or computer science majors who are looking to get ready for the FE exam, I am going to be doing analytical geometry with you guys. Now, based on my preliminary look at this section, this actually should be a lot easier to explain in detail because a lot of the mathematics behind it, well, that's pretty much it. It's pretty much mathematics. And this is pretty much right in my this is pretty much in my element because surprisingly I'm also a math instructor at Mathnasium. But let's not keep this introduction too long. Let's jump right into the section. So we're going to start with the first question right here. Number 1. What is the length of the line segment with slope 4/3 that extends from the point 6/4 to the y-axis? So let's go back to our handy dandy camera over here so I can start recording some of the variables. So the slope is 4/3. And then we need to worry about the point 6/4 that extends to the y-axis. Okay. Now the answer key generally uses the slope-intercept form for this, but personally I like to use the point-slope form because it keeps it a little bit more organized with where you want to place the variables, and so there's not much like, trying to figure out what b is or whatever. But if you want to do slope intercept form, that's perfectly fine too. Six, 4. Yeah, that's right. Okay, so usual algebra that we hopefully should have learned in our algebra class. I'm just kidding. We're engineers. We know what we're doing, right? Okay. So 8. And yeah, this equation correlates with what the answer key describes. So we have our equation now, but now we're trying to extend from 6/4 to the battery's almost dead. We're trying to extend all the way to the y-axis. Give me 1 second here. Okay, we're good. Okay. Now, from this point, from 6/4, that means, let me visualize this. So we're going 6/4, and the y-axis is about here. So that means there's a certain increment of x coordinates and certain increment of y coordinates that we need to worry about. So, but given the y-intercept is 0,4, so that means we gotta connect it from 0, -4 to 6/4. So now we gotta use the distance formula. Oh, +4. That's right, because 4 minus -4 is 8. Plus 6 minus 0 squared. So 8 squared plus 6 squared. And if you remember your Pythagorean triples, that's essentially square root of 100 equals 10. So that means our answer should be A. Okay, now that one out of the way, let's move on to number 2. Number 2 says, what is the following equations that describes a circle with center 2, 3, passing through the point -3, -4? Okay, so if you excuse me. So if you remember the formula of a square, it's essentially x minus h squared plus y minus k squared is going to equal r squared. So let's worry about the center first, hk, because that's a little bit more easier to handle. So our center was 2, 3. So we got to go x minus 2 squared plus y minus k. Though, I said I would minus 3 squared. But then it has to pass through the point -3, -4. So -3, -4. So that's -5 squared, that's 25, plus -7 squared, that's 49. So our radius is going to be square root of 74. So our answer is going to be D. Let's move on to number 3 next. So the equation for a circle is x squared plus 4x plus y squared plus 4y is going to equal 0. What is the coordinate of the circle center? So let's write out that equation. So if we remember now, we got to group our y and x terms together, and we also got to complete the square respectively for the x and y terms. So the way we were able to get the third term is, if you remember standard form, it's ax squared plus bx plus c, right? So, but since we want it to be a perfect square trinomial, if we're going to get c, we got to do half of b, then square it. So the b term is the one that only has the variable to the first power. So for x, that's going to be 4. Half of 4 is 2, and if you square it, you're going to get x squared plus 4x plus 4. And then for the y, half of 8, that's going to be 4, and then you square it, that's 16. So y squared plus 8y plus 16. But if we're going to make this equation equivalent, we have to add the 4 and the 16 that we added to the left side of the equation to the other side. So 4 plus 16 is going to be 20. Next, we have to simplify the perfect square trinomials into, binomials, but keep them squared. So our center is going to be -2, -4. Because remember, it's generally x minus h squared, but because it's a plus, we have to turn it into a -2. So if it's going to be -2, -4, our answer is going to be C. Okay, that wasn't too bad. Next up, number 4. Which of the following statements is false for all non-circular ellipses? Now, this is a conceptual question. A, the eccentricity the eccentricity E is less than 1. B, the ellipse has two foci. C, the sum of two distances from the two foci to any point on the ellipse is 2a, or twice the semi-major distance. Or D, the coefficients of A and C preceding the x squared and y squared terms in the general form of the equation are equal. So the general form of an ellipse is ax squared plus bxy plus cy squared plus dx plus ey plus f is going to equal 0. But if we remember the technical formula that we learned from, school, that's going to be x minus h squared over, well, it could be a squared or b squared. It could be either one, plus y minus k squared. Don't mistake it for minus, though, because otherwise that would be a hyperbola, where that equals 1. So essentially, but given this in mind, let's really think about this now. The eccentricity E is less than 1. No, that's true, because otherwise we're never going to be able to get that bendy shape we want. That's what makes it seem, well, almost like a flat circle, essentially, whether you're talking about it from the perspective of the x or the y-axis. B, the ellipse has two foci. Well, again, that's already inherent of the ellipse. C, the sum of the two distances from the two foci to any point on the ellipse is 2a. Yeah, because if you think about it from the center, that's why it's 2a in the first place. And, well, essentially by process of elimination, that would have to be D. And as the answer key put it, the coefficients preceding the squared terms in the general equation are equal only for a straight line or circle, not for a ellipse. And that's essentially true, because if they were equal, well, let's say like a squared and b squared were equal, then it would be a circle. So generally, like a squared would equal, let's take for example 9, and b squared would be 16. Then you would get something like this. Kind of looks like an avocado. Okay, let's move on to the next one. What is the area of the shaded portion of the circle shown? This is question 5. So essentially, the area that we're looking for here is essentially a sector minus a... Well, it's essentially a sector, but with a portion of it, only a portion of it shaded in. So let's find the sector first. So our variables are, the angle is 150 degrees and the radius is 7. So, but we want to convert this to radians. So 150 degrees is equivalent to 5 pi over 6. If you multiply this by 2 pi and then divide it by 360, or pi over 180, but doesn't matter. Anywho, so the segment that we're looking for, the area of the circular segment that we're looking for is going to be more akin to this. A is going to equal r squared. Phi minus sine phi divided by 2. So r squared is 49. And phi is going to be 5 pi over 6. And now sine 5 pi over 6. So if you think about it in terms of the unit circle, sine is generally referred to for the y value, so sine 5 pi over 6 will have to be half. All of that divided by 2. So 49 over 2, 5 pi over 6 minus half. So if we do common denominators and simplification, this would essentially be well, there's one trick we can do here. So if we times this entire quantity by 6, we got to divide the other fraction by 6 to keep it equivalent. So minus 5 pi minus 3. So that answer comes out to be B. All right, number 6. So a pipe with a 20 centimeter inner diameter is filled to a depth equal to 1/3 of its diameter. What is the approximate area in terms of flow? So essentially you've got a fluid going through a pipe with a diameter. So if the diameter is 20, that means the radius is going to be 10. So let's fill in our diameters here. So once again, it's another shaded it's once again another shaded area problem. So let's draw this out. Okay, so let's say this is about 2/3 of the area and this is the fluid going through the pipe. So 10, 10. So remember how this is like very similar to number 5 right here. So we got to figure out what this angle is right here. So if this is 2/3 of the way, that's going to be 20 over 3. So we've got our longest length of the triangle here, and this is 10 for each of the legs. So our phi is going to be it's going to be twice because you can essentially make 2 right triangles here. And then this will be 10 for each of the triangles, but the length right here will be the same. And the reason why it's cosine is because from here to down here, that's 10. But the liquid is filled up to 1/3 of the entire diameter. So this small length of the triangle down here is about 3 1/3, making this the hypotenuse. So adjacent over hypotenuse. So that's why I'm adding the 2 right here, because these are 2 equivalent triangles right here with the same angle here and here. Then we just need to you get what I mean. So we got 2 arc cosine 3 1/3. and your phi should roughly be about 2.46 radians. And now we go back to that same equation that we did in number 5. So 100, 2.46 minus sine of 2.46. Let's cancel out the 2 here. So when you come up with the sum, when you come up with the total calculation, that should be roughly about 91.5 centimeters squared. So the closest we can get to for an answer is C, 92. All right, excuse me for a little bit. I need to use the back side of this paper. Okay, number 7. So the equation y is equal to a1 plus a2x is an algebraic expression for which of the following? A cosine expansion series, B, projectile motion, C, a circular and polar form, or D, a straight line. Well, this looks already pretty straightforward. So y is going to equal to a1 plus a2x. Well, that's essentially analogous to b plus mx, which if you rearrange it commutatively, that's mx plus b. So that's just a straight line. That would be the answer D. So next we got to do number 8. A circular sector has a radius of 8 centimeters and an arc length of... kind of forgot what the symbol for arc length was. God, I feel dumb. Okay, I'm going to make like a little arch right here because that's generally what arc length looks like, of 13 centimeters. Most nearly, what is its area? Okay, so you've got a sector right here, 13 and 8 for the radius. So if you're going to find the area of a circular sector, you're going to have to extend it to one equation with like so. A is going to equal half the arc length. S. Oh, God, that was dumb. Hey, scratch that. So the area of your sector is going to be half the radius times the arc length. Very similar to the area of a triangle. So half times 13 times 8. Cancel the half out. We get 4. A should be 52. And that answer is going to be C. Number 9. The equation negative 3x squared minus 4y squared is going to equal 1. The options are a circle, an ellipse, a hyperbola, or a parabola. So according to the answer key here, it says that our general form of the conic section is ax squared plus bxy plus cy squared. plus dx plus ey plus f is equal to 0. Well, in that case, a is going to be -3. C is -4, and f is -1. So if a and c are different, this is definitely not a circle, so we need to figure out what the discriminant is. Now, funny enough, remember how we use the discriminant a lot for figuring out perfect square, well, trinomial solutions? Well, surprisingly, you can also use the discriminant for figuring out if the discriminant is less than 0, b squared minus 4ac, you can determine if it's a circle or not. So if it's 0, you get a circle. If it's less than, you get an ellipse. So let's do it. So we got no b, so that's just 0. We have a and c, so negative, negative, and a -4. So that's minus 4 times 3 times 4. -48. So that should be an ellipse. B. All right, 2 more to go. Number 10. What is the approximate surface area, including side and base, of a 4-meter high right circular cone with a base 3 meters in diameter? So our radius is our diameter is 3. So the radius is 1.5 and the height is 4. Total surface area of a right circular cone. So that means we need to figure out the base area and the area of the, cylinder, cone. So that's going to be pi r squared plus pi r. Okay, this is where we apply a little bit of Pythagorean theorem. So we know that a cone is generally, this, but more circular. So that's what the length of the... You ever take like a piece of paper and you fold it to make it look like a cone? That's how we're going to solve for this length right here. Essentially almost like the width of the paper. So the variable that we're multiplying is pi r times r squared, the radius, plus h squared. Okay, let's plug that in. And if you use your handy dandy calculator, you should be able to get something like... Hang on 1 second. Roughly 27.2. So, meters. Our area is going to be answer B, approximately. All right, last question. Why'd I write 9 there? That should have been number 10. Okay, never mind that. I don't know what's wrong with me today. What is the approximate area of a circular sector with a radius of 4 and a central angle of 10? So R is going to equal 4 and the angle is 10 degrees. But remember though, we're going to want to convert this to radians. So times pi over 180. That's going to be pi over 18 radians. Now, accordingly, our equation is going to be half r squared times phi. We'll generally use pi because 180 degrees, but because we've only got a sector, that's why we use phi right here. So it's just going to be half times 4 squared, 16 times pi over 18. Calculate that, and you're going to get 1.4. That sector area is answer C. Okay. We made it through the entire section of analytical geometry for the electrical and computer section for the FE exam workshop. Thank you guys for taking the time to watch this and gain a little bit of an edge if you ever decide to take the FE for your career. And I know we're doing YouTube videos a lot lately, but don't worry, we're based on the numbers with the pandemic and everything, we should be getting back to normal sometime soon, hopefully. I know today is like the peak of coronavirus victims today, and also the resource usage. But don't let cabin fever get to you guys, and make sure to have some fun. Like, I don't know, maybe drink a few White Claws here and there. Actually, that's what I did before I did this video with you guys. All right, you guys hang in there, okay? I'll see you guys in the next section of the FE exam. Peace out, guys.